Hello, Papa.
Hello, bache. How are you?
I'm doing great, and today we are going to learn how image detection works, how blurring of images works, and how image creation works. Does that sound interesting?
Yeah,
Yes.
definitely.
Lighter on the left side and darker on the right side. This method is called convolution. Move it like this, then move it like this. From top, I'll move down.
Is CAPTCHA based on the...
So what have we learned so far?
We can move it from 1 to 3. Where is this used?
Okay, so let's get started.
Yeah, sure.
Do you know how images are stored? Like there are pixels within images.
That I know.
That you know.
Yeah,
so
yeah.
every pixel has a value. Do you know that?
Yeah, definitely.
Right. So like black is 0, white is 255, and in between all like colors are there with different values of RGB values.
This
right?
much I know, yes.
Okay, great.
Okay.
Awesome. So this is all that we need. Now
Okay.
for explanation purposes, let me simplify it a bit and let's take a black and white image.
0 to 250.
Yeah, so there will be only two values of the pixels, either 0 or 255.
Okay.
So you will be able to understand for further colored images as well, but for simplicity, we are just going to take 0 and 255.
Okay.
Sounds good?
Yeah, definitely.
Okay, great. Okay, so let's take an example. Suppose I have an image of suppose, what is this?
Looks to be 7.
7, correct? So let's say this entire thing is colored and this, like the rest is just white. Okay, so
Colored means black.
yes, so this is entirely going to be black.
Okay. And
Okay.
the background is white.
Correct.
Okay.
So now if I divide this into pixels, something like this.
Yeah.
Okay.
Okay.
So you get the point that there will be like different pixel values over
Certainly.
here. Right?
Yeah.
So because it is white over here, what will be the value? 255.
255, yeah.
Right? And for black, it will be 0.
Yeah.
Right? Before we move ahead, I would like to ask you if you know that in our Educosys GenAI course, I didn't just cover the application side, but I also covered the basics of GenAI. So neural networks, RNNs, LSTMs, we literally wrote the transformer code, went through the white paper, went through the DeepSeek white paper. We have done so much. You have to check out the testimonials. Plus, if you're preparing for interviews, then I have courses on DSA, LLD, HLD. We have courses on C++. There is so much. You have to check out the testimonials at least. Even the LinkedIn profiles of all our testimonials are added over there for credibility, right? So you should know that if you like my teaching style, I love teaching over there. We are building a great community and so many people are already part of it. At least check out the details in the description. So now I want us to think that over here, let's just consider this part. Okay. So there is one edge that is starting over here. So the color over here is black. But over here it is white. Correct. So here the value is 0 and here the value is 255.
Okay.
So how can we detect that, okay, there is one vertical edge that is coming over here?
I think as soon as the value abruptly changes.
Yeah. But also, like we also want to extend this same concept for colored images as well, right? So we want to understand that how will we come to know when the shading is happening. Suppose we are going from a lighter shade to a darker shade. Or from a darker shade to a lighter shade. Okay.
So the pixels will decrease here and will increase.
Correct. Now, mathematically, let me give you some calculation that from the calculation, how can you understand? Okay. So now what I'm going to do is, I'm going to take a 3 by 3 matrix. You understand what is a matrix?
Yeah, definitely.
Yes. Okay. So I'm going to take 1, 1, 1, 0, 0, 0 and minus 1, minus 1, minus 1. Okay. So currently the pixels are how it is going to be something like this 0, 0, 0, 0, 0 and there's going to be 255, 255, 255. I'm just considering this part of the image right now, like this part. Okay, so suppose there are like 3 by 3 pixels over there and this is one extra matrix that I'm taking.
Near the edge.
Yes.
Or the edge.
Yes. Yeah. Okay, so what I'm going to do is this value I'm going to multiply by this value by this value by this.
The like matrix multiplication basically.
Dot product.
Like
value by value, right? So because here it is plus 1, the value is going to be like 255 plus 255 plus 255. And the rest is going to be all zeros? Correct?
Yeah.
So, because the value is so positive, now you understand that there must be like, lighter on the left side and darker on the right side. Similarly, if it was like the other way around, if it was 0, 0, 0, and if it was 255, 255, 255, 255, 255, 255, and suppose the matrix that we have taken is like 1, 1, 1, 0, 0, 0, -1, -1, -1, -1. Okay, so you're going to multiply these values. So this is all going to become 0. This is all going to become 0.
And this will be 255, 255,
so negative 255.
Negative 255.
Right? So because now the value is negative, so you understand that there are higher values on the right side.
Right side.
Because now when you multiply -1 and when you multiply 1, then values, the
Definitely.
product is coming negative.
Definitely.
So the values are greater on the right side.
Right
so
side.
it must be lighter on the right side.
Lighter on the right side.
So you understand the concept. So mathematically, this is how you can understand that the values are going from dark to light or from light to dark.
Okay.
Right? So what we just did is vertical edge detection.
Vertical?
Edge detection. So this is a vertical edge.
Okay, yeah,
correct.
Yeah, agreed.
Right. So right now I had taken like 1, 1, 1, 0, 0, 0, -1, -1 like this. If I take like this 1, 1, 1, 0, 0, 0, -1, -1, -1, what do you think I will be able to detect?
Horizontal
edge detection. So if suppose I have my 7 like this, right?
From the top side and
correct. So I will be able to understand that there is a horizontal edge or there is a color change happening like this. Right? So this method is called convolution. Convolution. So here what we do is we take a smaller matrix, this one. We are going to call it a filter or a kernel.
Okay.
And we take the smaller one when we go across this bigger image and we understand where vertical edges are present, where horizontal edges are present. Like currently we took only this part and we understood that okay, there is vertical edge over here. But because we are taking 7, there is like 7. Okay, there is 7. So there is vertical edge over here also and over here.
But there is a slant edge. What will happen to that?
So correct. Very good question.
You are a good question.
So there can be slant also, right? So we can take filter like this 1, 0, 0, 0, 1, 1, -1, -1, and suppose -2 and 2.
Okay.
Correct. So like this, the smaller matrix or the smaller filter that we are taking, it can vary and I will be able to detect vertical edges, I will be able to detect horizontal edges,
And
I will be able to detect diagonals. Similarly, there are filters available for like detecting circles. For different things. Okay. So isn't this beautiful that just by convolution, by taking this small matrix and see, this bigger image can be of any length. It can be 128 by 128, 256 by 256. It can be of any length. But I'm going to take a 3 by 3. So suppose it is like this. I'm going to take the 3 by 3 matrix over here, then move it like this, then move it like this, and I'm going to keep detecting that where am I getting. Like similarly from top I'll move down, then I will move down.
Vertically then horizontally.
Yes.
Okay.
So I'm going to go through the entire image and find that what are the different edges that are present, right? Any different kinds of patterns that I can find.
And based on that you'll be able to decipher whether it is 7 or something.
Exactly.
क्या बात है सर? क्या बात है सर? क्या बात है? ये बात है.
Okay.
So neural networks, you remember the concept of neural networks?
Yeah.
Yes.
Definitely.
Yes. So what happens over there is key small patterns we understand and we together understand that these small patterns together are forming a particular image kind of thing, right? So suppose I have to detect 7. I know that in a 7 there is a vertical edge that will come over here and maybe a slant edge or a straight edge. Maybe 7 can also be written like this, right? So this might look like a vertical edge. So based on training, our neural networks will understand that this is how 7 looks. There is a horizontal line, there is a vertical line. So all of these images are 7.
But your model will have to be trained to call this as a 7. Otherwise it may not call it as a 7.
Correct. So that is a label. So based on a lot of data, we will understand that, oh, this is 7, this is also 7. Like suppose this is 9, but this is also 9. Correct?
Like some people may write 7 this way also.
Correct.
Then
yes. So that model has to learn based on a lot of data that is present.
Okay.
Correct. But you understand that how detection is working, right?
Now you have made
small patterns.
Definitely.
So you just have to understand. So like this, see, the more the number of filters that you have, like right now I'm able to detect vertical edges, horizontal edges, circles and all of this. So the more the number of filters I have,
better the accuracy.
Yes. In the end, just think about it. You can extend this concept to any image. Think of dogs or cats, dogs. In the end, there are like, ears. So, okay, you understand that there should be an ear like this. Or just for eyes, humans or animals, you know that there should be a circle, that there should be an oval. And this is the basis of detecting any kind of images.
Okay.
Isn't this beautiful?
Definitely.
So, just by this Pure maths. It's just pure maths.
Is CAPTCHA based on this?
Yes.
Okay.
It's all based on this. So you take small filters and you just go through the big images. You detect the patterns and then you understand these patterns together are like forming which kind of image.
Okay, great.
Beautiful?
Great.
So now you have understood how image detection works, right?
Definitely.
Let's extend the same concept to understand how blurring of images might work. Okay. Now think of it again. Images are like pixels, right? Like huge.
Definitely.
Like right. So when we take this image, now there are many colors that are like pixel values, right?
Okay.
So let's say one value would be say over here it is white. Over here it is completely black. Oh, sorry, I'm saying opposite. So these are white, these are black. And suppose this is white. Black. Okay. Now when I take this big image and maybe instead of storing this value in 9 small pixels, I want to store it in a small 1 pixel value. So what I'm going to take is, I'm going to take an average of this.
Okay.
Right. So it might become something like gray because there are 9 values and there are 4 255s. So it will become 4 into 255 by 9.
Yeah, definitely.
Correct. So if you think about it, again, I'm doing convolution only. How am I doing convolution? My filter is now 1 by 9, 1 by 9, 1 by 9, like this.
Okay.
And I'm going to take this filter and I'm going to take it on these 3. Then move it, then these 3, then move it, then move it.
Understood.
So what is going to happen if I had a 9 by 9 matrix?
Okay.
And now let's see. So I had something like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are like 9 rows.
And 9 columns.
Correct. Okay. So now this 3 by 3, I'm going to move it to 1 pixel.
1 pixel.
This also I'm going to move to 1 pixel. So now there are many ways of moving it. Either I could move this or I could move like 2, 3, 4 into 1 pixel. Then 3, 4, 5 into 1
Either
pixel.
1, 2, 3, then 4, 5, 6 or
correct.
In steps you can move it.
Yes. And I'm taking average of that. So see, on a higher level, it will still be same. So instead of black, it might become like dark gray. And instead of like
something between white and black.
Yes. And similarly, if you're moving from say red to say light pink, it will be some values in between.
Definitely.
Right? And then it will look like blurred. It will give you an illusion of blurring.
Every color has a pixel value?
Yes. So there are actually 3 values, RGB values.
RGB, I know.
Red, green, blue values. But currently, because we are considering white and black, so there are only 2 values that we are considering. Like you can think of it like 0, 1 or 0 to 55, right? But this is the concept. Are you able to visualize it? That when you move it, how it has become like an average of that?
100%.
Yeah.
So what have we learned so far?
Basically, any picture is consisting of pixels. So as you said, white is 255 and black is 0. So it can be divided into pixels. And then we learned about the process of shifting of the matrices.
The smaller matrix is called?
Convolution, you said.
The process is called convolution. The smaller matrix that we move like this, it is called filter or kernel.
Filter or kernel, okay.
Okay.
Yeah. No, sorry, I didn't get it. Sorry. And this is what we learned.
Okay.
And similarly for other colors also, if you want to visualize a blurred image, because abruptly you are not, and then we learned about the image detections, how the horizontal edges are moving, how the vertical edges are moving.
Can you give a try at how vertical edge detection filter is going to look like?
Filter means the matrix.
The smaller matrix.
Okay. Like this is the vertical axis. Sorry, this is the vertical axis. Yeah. And
the matrix.
This will be white. You said is 255, and black is 0. So it will be 0, 0, 1.
I don't know.
Oh, 255.
Okay.
Then 0, 0, 255.
Opposite, but okay.
What opposite?
Like this is black, right?
Yeah.
So this should be 0, this should be 255.
Okay. Let me use the duster. So it will be 255
Hmm.
0,
Hmm.
0.
Hmm.
255, 0, 0.
Hmm.
255, 0, 0.
So this is this image ka pixels.
Yeah.
Now the smaller matrix that I'm going to take and I'm going to move it like this, the filter.
As you said, was 1, 0, minus 1. Then 1, 0, minus 1, 1, 0, minus 1.
Very good. Nice. Why did we take like this? So that we are able to understand the difference between the vertical.
We are moving from
left
to right.
Or right to left, one thing. Yeah. And if we want to detect horizontal edge, then this will change how?
This will change as 0, 0, 1, then 0, 0, minus 1.
Think of it. So because we had to detect vertical edge detection, there was 0 in between. There was 1 like this and minus 1 like this. Now horizontal edge.
Okay. 1, 1, 1, 0, 0, 0, minus 1, minus 1, minus 1.
Very good. Blurring, how will this look?
Blurring, as you said, suppose this is a matrix of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. We can move it from 1 to 3 to 4, 5, 6, or we can move it from 1 to 2, 3, 4, then 3, 4, 5, then 4, 5, 6, depending.
The smaller matrix, how will it look like? Like this is called filter, right?
Filter, yeah.
So for blurring, what filter can I use?
I'm sorry.
So we have to take average of 9 pixels.
Oh yes, average of 9. Okay.
Yeah.
So
you know everything, just think.
yeah.
Because here we had to detect vertical, so there is 0 in between, there is darker over here like this,
and
right?
if you take the average, say suppose it is 9 matrix. So
Correct.
it will be 1 by 9, 1 by 9 and 1 by
9 values in the
9
matrix.
values in the matrix.
Very good. Nice. Let's now move on to the final part of the video. We are going to discuss image creation. Okay. And so till now we talked about detections. There are images that we already have, but how does image creation work? Okay. Now there are many solutions out there, okay? And there's a lot of research that is still going on. There are a lot of topics for viewers, just letting know that there is GANs, there is VAEs, there is diffusion models, and there's a lot more things. But for simplicity, I'm going to take one simple approach and just explain to you. Okay. Okay. And we are going to be talking about GAN, G-A-N.
What does this stand for?
Generative Adversarial Network.
Adversarial?
Yes. Network.
What does mean? What does
adversarial? Do you know the meaning of adversary?
Adversity, I know, but
adversarial meaning enemies.
Yeah, adversity is some odd situation. Yeah.
Correct. So here what?
Generative adversarial network. Okay.
So you know neural networks now.
Yeah.
Correct. So what we are going to do is we are going to take two networks and we are going to make them fight against each other.
Okay.
Okay. So what one network will do? So we will have two networks called generator and discriminator.
Okay.
So what is going to happen is that this generator model is going to be responsible for generating images. It will try to generate fake images. And what this discriminator will do while training, it will try to understand whether this is a real image or it is a fake image. Okay. So now both of them are competing against each other. So now generator is trying to become better at generating more fake images and discriminator is trying to become better at understanding whether this image is fake or whether this image is real.
Great.
Right. So at any point, only one of them is going to win. Correct. So how a training is going to look like is this generator is going to generate one particular image. Okay. Okay. And it is a fake image. Now discriminator has a lot of images. It has some real images. It has some fake images.
So it compares the...
Now it is going to pick this image and it is going to just check whether this is a real image or it is a fake image.
Okay.
If discriminator is able to understand that this was a fake image that I have, then who won in this case?
Discriminator.
Then discriminator won. Yeah. But if it was not able to tell and it says then generator won.
Yeah.
Right. So in training, both of them will fight against each other till we are sure that generator is able to create images that are like that seems real enough to discriminator.
And discriminator is able to detect that those are not real, those are fake.
Those are like discriminator is not able to understand that this is fake images, but it seems real to discriminator, right?
Okay.
Then your generator is actually winning in generating real kind of images.
But what is our purpose? To create a fake image or to create a real image?
To create an image that is fake, but it looks very real.
Oh my God.
That is how image creation
So
is
our
working.
aim is that generator should win.
Yes.
Okay.
But our aim is that the generator should win. So during training, both of them will fight each other. But in the end, when we use this model, who is going to do the work? Generator is going to do the work, because the goal is to generate images.
Okay.
Right? So there are many concepts like this that is used. That is why this is called
By the way,
generative.
where is this used? Why do we need to create images which look like real but are not real?
So think of any, like ChatGPT, you must have seen, we ask ChatGPT to create images these days, right? Or
Okay.
Mid-Journey or all of these. How does this work? Internally, so everything started from GANs, then came VAEs, then came diffusion models. Now most of these big companies are
Become
using
more
diffusion
complicated for me.
models.
Let us concentrate here.
Yeah, so this is
Okay.
the like one of the ways.
Okay.
Okay. So did you understand?
Yeah.
So explain.
Definitely. You said it is basically a GAN, generator adversarial network.
Generative adversarial network.
Generative adversarial network.
Yeah.
Then you said basically the purpose of the generator is to create images which look like real but are fake. And the role of the discriminator is to identify whether it is fake or real. Initially, when we are training the model, discriminator and generator will fight with each other. But a time will come when generator will be able to generate images which look like real but are not real, and discriminator will not be able to detect those, and then generator will win.
So now when you use ChatGPT, you know that internally this could be one thing that is happening, right? So ChatGPT would have seen like a lot of images and the training would have happened between two models. This is just one way. Obviously, big companies don't use this anymore.
Okay.
There are better ways, but okay, this is one way. Nice. Did you enjoy the video?
Definitely. Something always new learning.
Yes. So you understood blurring of images, image detection, image creation.
And if you have understood, do share, subscribe, and if you want to understand more, share with your friends also.
If he is saying, you have to do it, right, Matlab?
Thank you.
Thank you. Bye.
Bye.